Assalamualaikum and hello everyone. We are from Group C, consisting me, SYAFINA, and my fellow members Limin, Shajwan, Dania, and FARHA will be presenting STS 3410 Logistic Regression. We will begin with the introduction. Early and accurate coronary artery disease risk prediction is essential for effective management and treatment. A research was executed to develop a new way to predict the likelihood of coronary artery disease using data from patients at the Cleveland Clinic. The Cleveland data from this research is used to apply into logistic regression. The diagnosis of whether a patient has a coronary heart disease is calculated through logistic regression analysis using RStudio and interpreted. By examining a combination of categorical and numerical variables, this research aims to develop a reliable statistical model that clinicians can use to assess heart disease probability. Let's move on to the data source. The dataset utilized in this research was obtained from the heart disease dataset available through the UCI Machine Learning Repository. It compiles patient data from multiple locations, including Cleveland, Hungary, Switzerland, and also California. The processed Cleveland data is used to fit a logistic model. So this is the list of variables in the processed Cleveland data. So that's all from my part. I will pass to FARHA.
My name is FARHA and now I will explain about the exploratory data analysis. For the handling missing data, the mode imputation method was employed, saying removing row can introduce bias, and the dataset was re-evaluated to confirm that all the missing value has been successfully addressed. This was verified when reported zero missing value across all columns. Step 2 ensures that the target variable is compatible with logistic regression by encoding it into a binary outcome. Meanwhile, step 3 ensures categorical predictors are treated as discrete variables, enabling the model to interpret them correctly and provide a meaningful result. Based on the p-value of set statistics, some variables are significant at 50% significant level, meanwhile some are not significant in this model. This indicates that there are some variables that could potentially be dropped from the full model. To identify this, stepwise regression should be performed. From the model summary of stepwise regression, you can see that CP4 and CA2 has the highest value of coefficient, which means that they are the most significant predictors. Also, the AIC value decreases from 228 to 222, which means that the model performance has been improved. Next, the odds ratio were obtained by the exponentiate the coefficient, and we can also see that CP4 and CA2 has the highest value of odds ratio.
Thank you, Farha. Now I will talk about MLE. For the sample label as 1, we will have function equals to pi px, and for 0, we will have function equals to pi 1 minus px. And multiplying these two, we will get likelihood functions. After that, we take log, substitute px, and simplifying, we get log likelihood functions for optimization and also estimation. Next, to maximize log likelihood functions, we use Newton-Raster method. We use coefficients of current iteration minus first derivative divided by second derivative to get the new coefficients. The iteration will be stopped when optimization has been reached. And you can see that there is equations for first derivative, second derivative, and also matrix representation for the equations of iteration. It will be used in R. And also the results of MLE is close to the results of GLM. And next, I will pass to Limin for assumption testing.
Alright, thank you, Sanshan. Now let's move to the assumption checking for our model. First, the dependent variable is binary with outcomes coded as 0 for no and 1 for yes. This satisfies the assumption. Next, the scatter plot matrix shows an approximately linear relationship between the logit and continuous predictors, such as age, trace BPS, call, and opaque. This relationship confirms the linearity assumption. To check independence, the Derby-Wilson test gave a result of 2.0317 with a p-value of 0.608, indicating no autocorrelation in residuals. Additionally, there are no duplicate entries in the dataset, ensuring observations are independent. Multicollinearity was assessed using the GBIF and all values were below the threshold, confirming no significant multicollinearity. Next, the sample size of 303 exceeds the minimum required size of 283, ensuring it's adequate. Code distance indicates no influential outliers because the top 3 of the absolute standardized residuals are all below 3. Lastly, to ensure the model is appropriately specified, we already performed stepwise regression, which evaluate the significance of each predictors. Irrelevant variables were excluded. That's all for my part. Next, I will pass to Dania.
Thank you, Limi. Now, I will continue for the conclusion. There are limitations in this research. First of all, the data came mostly from one clinic, which is Cleveland Clinic. Second, some possible risk factors like lifestyle factors may be missed, and it did not include advanced methods like machine learning. Last but not least, simplifying the model may have left out important details and affected the accuracy and applicability of the results. In conclusion, the study built a logistic regression model to predict heart disease by using the benches data. The model focused on key factors like blood heart vessel, chest pain type, gender, exercise-induced symptoms, and blood pressure. The results show that having two blood vessels increased the odds of heart disease by 90 times, and certain chest pain types also raise the risk. The model met all statistical requirements and could help doctors assess heart disease risk. So that's all from us. Thank you.